And welcome to our second tutorial. In the second tutorial, we're going to look at an HK form and then translate it into a different form and see if we can make some connections for our later functions. So let's look at example number 3 in our notes. This again is in an HK form, and let's go ahead and start by graphing that. Vertical asymptote is x equals 3, because that's the numerator, that's the denominator's value that would make a 0. So I'm going to put that into my graph at x equals 3, and there's my vertical asymptote. And my horizontal asymptote, I label that with an HA, is the value of 2, so y equals 2. And let me dot that in, or dash that in, 1, 2 on the y-axis. There we go. When I try to graph my points, I notice that A is equal to 1. So when I get my cross section, or right here in my intersection point, I go over 1 to my 1, or up 1 to my 1. Either way, it's just going to be that 1 right away. And over here in this section as well. And I can graph this part.
You can't touch this.
And I can graph this part.
You can't touch this.
This is just some review from our previous tutorial. Let's look at our domain and range. I'm just going to do set notation since I don't have that much room. I like the set notation, everything except for 3 for the x, and for the y, everything except for 2. My end behavior, I'm going to again choose to describe with the plus or minus. And in this case, my end behavior, well, if you haven't noticed yet, it's always going to be approaching this value that the horizontal asymptote is. H of x is trying to become 2 on the far right end and on the far left end. So that's just a review example. What I'd like to do now is, because we're not always going to be given a rational function that's in HK form, so it's not going to be that simple to find our asymptotes. What I'd like to do is take this rational function, this 1 over x minus 3 plus 2, in fact I'm just going to put it 2 over 1, I'd like to combine them together, these two fractions, to make one fraction. And let's see what happens and see if we can make a connection. Obviously they don't have the same denominator, so I'm not able to add them yet. This denominator is an x minus 3, which means that this denominator needs to be an x minus 3. So I'm going to go ahead and put this in this denominator, but I have to do it to the numerator and the denominator so that I'm not changing my fraction. Now they'll have the same denominator, so I can combine these two fractions together that have the same denominator, and let's see what I have. I have my 1 and then my plus sign. Let's go ahead and distribute here and get 2x minus 6. Okay, now let's combine our like terms in the numerator, and I have a 1 and a negative 6, which make negative 5. So I'll do 2x minus 5 divided by x minus 3. So this is still h of x. It just looks a little bit different. It's the single fraction now. But I'd still like to figure out how we can find our asymptotes from this equation. Well, you notice that our vertical asymptote is still going to be the same. I'm just going to come and make my notes over here. The vertical asymptote is still x equals 3, and that still just comes right from the denominator, as it always would. We still have the denominator of x minus 3, so our vertical asymptote isn't too bad. Our horizontal asymptote, which we know is y equals 2, do you see where the 2 is in this equation? I see a 2 right here, and that's exactly where it's going to be. I'm going to put this 1x down in the denominator because it really is both of these coefficients working together. But that's how we find our horizontal asymptote. Our horizontal asymptote is the leading coefficient. When our rational function is in a single term, we take our leading coefficient, that's the leading coefficient from the numerator 2, and the leading coefficient from the denominator 1, and take that as the number. Y equals 2 over 1. 2 over 1, of course, is 2. And there you go. Our leading coefficient would give us our horizontal asymptote. So maybe it's a little bit more difficult to find the horizontal asymptote, but we need to be able to do that. So we do have a couple rules to follow when we're looking for our horizontal asymptote. Again, this is when it's not in HK form. In HK form, it's pretty simple to find our two values, h and k, but when it's all one fraction, it's a little bit more difficult. What we need to do is we need to look at the degrees of the numerator and the denominator. In this case, the degree of the numerator was 1, because it's 2x to the first power, and the degree of the denominator was also a 1, because it's 1x to the first power. And if we can compare the degrees, then we can find our horizontal asymptote. Okay, so we must find the degree of the numerator and the denominator. And if the numerator's degree is less than the denominator's degree, then the horizontal asymptote will always be y equals 0, which is the x-axis. That's nice. In our last case, it was case number 2, in our last example. If the numerator's degree is equal to the denominator's degree, then the horizontal asymptote is the leading coefficient. Let me put y equals. Y equals the leading coefficient. That's if the degrees are exactly the same. And our final case is not really a case at all. If the numerator's degree is greater than the denominator's degree, then there is no horizontal asymptote. So we don't even have to worry about that. So those are really the three cases. So let's look at our final example in this tutorial. Let's look at j of x. It is not in standard form, in HK form, because we don't have the k out here. Somebody put both of the fractions together into one. Well, let's find our vertical asymptote first, since that's always going to be the same. We're always looking at the denominator, and in this case, x equals 2, because 2 minus 2 would be 0. So there we go. We'll go to 2 on the x-axis, and we'll put in our vertical asymptote. Now let's worry about our horizontal asymptote. And like I said, the horizontal asymptote, it depends on the degrees. It depends on the degrees. We need to see if the numerator's degree is less, or if it's equal, or if it's greater. Well, the numerator's degree is 1. Again, it's always the highest of the exponents that you see, and in this case it's a 1. The denominator's degree is also 1. So since they are both the same, this must be case number 2. And in case number 2, we're looking for the leading coefficient. And our leading coefficient is 3 divided by 1. So we have y equals 3. So I'll go into my graph and go to when y equals 3 and dash that horizontal asymptote. When we're talking about graphing the rest of this, when it's in one term, we have lost the value of a. It's hiding, so we don't really know what the value of a is. So in this case, I would just prefer to use our calculator. Just please remember to put parentheses around the entire numerator, since we have a binomial, and the entire denominator, and then we can sketch a graph using that. Let's pull up the calculator. This has the previous one that we were working on. Clear that out. I'm going to start with the parenthesis and then put in my 3x plus 1, and then divide and then use another parenthesis for my x minus 2 in the denominator. Again, the entire numerator and the entire denominator in my parentheses. I'll press graph and see what we've got. Yep, that's going to fit nicely into my shell, right? You can see that it's actually crossing a little bit less underneath the origin. Let me move this over a little bit more and
You can't touch this.
do this. It's actually doing something like this, and this part's doing something like this. In our next lesson, we're going to be talking about x and y intercepts, and that'll help us to flesh out this graph. But for right now, I want you to make sure you can find the vertical and horizontal asymptotes and be able to sketch the curve. Let's talk domain and range, and then we'll be finished here. Domain and range, I'm going to do set notation again, all x such that in this case, x cannot be equal to 2. Feel free to use interval notation if that's what you prefer. And the range, I'm going to do set notation. I just feel like it's less writing. Y cannot be 3. And since that's the what y cannot be, that's going to be what our end behavior is. As x approaches either side, plus or minus infinity, in this case, we have j of x is trying to get to 3. And there's our end behavior. Thanks for watching this second tutorial. I know we have some practice to have with this material, and I'll see you in class if you have any questions. Bye-bye.